Hi all, my name is Erisa Wante. I'm a graduate student at Oklahoma State University in the United States. I was a teacher in Uganda for about 10 years, teaching mathematics and physics to mostly the A-level students. So I understand what's going on in the country right now. There is a pandemic and all of children have been kicked out of school. So I'm taking this opportunity to resume my online classes. I used to do sometime last year, but I halted the program because I became so busy afterwards. I feel for the students who are really at home, not studying, and it is painful at the time when you're supposed to be getting some knowledge, but something is stopping you, something inevitable is stopping you, and there is no way you can, go about it. So you have to stay home. So you take this opportunity and learn something in mathematics. Let's do trigonometry. Trigonometry comes from two Greek words, trigonon, that means triangle, and metron, which means measure. This is a branch of mathematics that studies relationships between sides of a triangle and the angles of the triangle. So trigonometry will define for us trigonometric functions, and these functions will describe the relationships we want to look at between the sides of the triangle and the angles of a triangle. So in trigonometry, basically, what we are going to study is the relationship between the angles and the sides of a triangle. Just that. But why do we study these relationships between the sides and angles of a triangle? There are so many applications of trigonometry. One of them is geodesy, okay? Geodesy is about understanding Earth's geometrical shape, orientation in space, and the gravitational field. Then we have seismology, meteorology, and the oceanography. Now, seismology is about seismic forces, tectonic forces, like earthquakes and, those forces you study in geography, and that's seismology. Meteorology is about the parameters of weather. You try to predict, is it going to be rain, is it going to be, and the oceanology is about mapping the ocean. So we use it in electrical, mechanical, and civil engineering, in computer graphics. In medicine, we use trigonometry. In a city, if you have been to the hospital and you take a CT scan or ultrasonic sound, you will see that there are some curves that keep coming on the screen, okay? That's an application of trigonometry. We also use the trigonometry in optics and acoustics, in surveying, in celestial mechanics, and in navigation. If you're gonna find your way on the sea, on the lake, you got to have some knowledge of trigonometry. Next, let us discuss trigonometric ratios. Trigonometric ratios, are the ratios between edges of a right angled triangle. Okay, so when we try to talk about trigonometric ratios, we mean the ratios between the sides of a right angled triangle. You have talked about some of these ratios at ordinary level, okay? You say the ratios are, these are the ratios you discussed at the ordinary level. You discussed sine, you discussed the cosine, and tangent. So at this level, we are going to talk about sine, cosine, and tangent, but we shall have to bring in the reciprocals of these ratios, okay? So let's consider the right angled triangle, okay? Let's consider the right angled triangle below. Okay, this is your introduction. I'm trying to remind you what you discussed at ordinary level before we really start looking at serious work at this level. But you need this knowledge. We can't just jump, Jumping has caused trouble to so many students. You assume something has been covered, and then as you go on with the lesson, you discover some knowledge somewhere is lacking. So I don't take that. I don't do that, no. I have to look at each and everything before I move on. So let's consider the right angled triangle below, okay? You have a triangle, okay? Oh my God, I'm drawing like a drunkard. Okay, so this is a triangle we want to talk about. It has a 90 somewhere. That's how we indicate a right angle triangle. And we are looking at this angle, let's call it theta. Now this side, okay, this side or this edge has length A. It's the edge which is facing the angle, and we call it the opposite. Okay, now the edge that meets the opposite at 90 degrees, let's say it has length B, is what we call the adjacent. And the longest edge of a right angled triangle is going to be the hypotenuse. So let's say the hypotenuse has length C. Okay, now we define the sine function. Okay, you define sine function is defined as the ratio of the side, okay, opposite the angle to the hypotenuse. Okay, you have defined the sine. I'm just trying to, I said I don't take anything for granted. So sine is defined as the ratio of the opposite. You get this length of the opposite and divide it by the length of the hypotenuse. Now, if we want to write sine of an angle, you want to indicate sine of an angle theta, in this case, the sine of theta, okay? You drop E, and where there's E put there, the angle, in this case is theta, is the opposite. The opposite has length A. When we refer to this triangle up here, the opposite has length A. Okay, this is the opposite. The length is A, and therefore, let me rub it. I don't want to mess up my work. Okay, and therefore we can see that the sine is A divided by C. Okay, that was defined, but I have to remind you. Then the next function, let's call this equation 1. This equation 1. The next function is cosine. Okay, we have cosine function is defined as the ratio of the adjacent side to the hypotenuse. So cosine, just look at the adjacent, length of the adjacent, and divide by the hypotenuse. That will be the cosine. So if you are to write, you write here. Okay, we have the adjacent as this side. The side that meets the opposite at 90 degrees is gonna be the adjacent. So if you look at this triangle, then the adjacent has length B, and the hypotenuse has cosine equals to, let me try to be consistent and use the same color for this function, is cosine is adjacent. You get the adjacent and divide it by the hypotenuse. In our triangle, if we refer to our triangle here, it's C. So this is gonna be B out of C. Okay, so we can say that cosine, if you want to write the cosine of an angle, then you drop the INE and write cosine of angle theta is B out of C. Let this be our equation 2. Okay, so what else are we left with to define? We have to define tangent. Okay, tangent. How do we define tangent? Tangent, okay, function. So tangent function is defined as the ratio of the opposite side to the adjacent side. So we write tangent is opposite divided by the adjacent. So if you want to write tangent of the angle, okay, then you have to drop the GENT and replace it with the angle theta is the opposite, in this case A divided by B. Okay, so this is equation 3. We shall make reference to some of these equations in the future as we move on. Now there is something so important that we can discover about tangent. Okay, let's get equation 2 and equation 1 divided by equation 2. Okay, you have equation 1 divided by 2. Okay, we know that equation 1 is the sine of theta is A out of C. Then equation 2 is the cosine of theta is B out of C. Now you have looked at some of these fractions. Okay, if you are dividing two fractions and the numerator and the denominator, have the same denominators, the fraction in the numerator and the fraction the denominator have the same denominators, then it cancels out and you end up with A out of B. But okay, we have just seen that the tangent of the angle theta is A out of B. So what does this mean? Okay, something so important here has been discovered. We have discovered that if we divide sine theta by cosine theta, we exactly get the same thing as somebody who looked at tangent, okay, tan theta, and that's the same thing as A out of B. So those two are the same. Sine divided by cosine is gonna be tangent. So tangent can be written in terms of sine and the cosine. That's something so cool and so important, and we shall use in our discussion as we go on. Okay, so if you want to remember what ratios give you sine, cosine, and tangent, we can use the word. Okay, we can use the word SOHCAHTOA. Okay, I will change this color and write it as SOHCAHTOA. Okay, we can use this one to remember. Okay, to remember what sides of the right angled triangle are equal to sine. Okay, what sides of the right angled triangle are equal to sine, cosine, or tangent. Okay, so this word SOHCAHTOA here, we are using the word SOHCAHTOA. So okay, SOHCAHTOA. This is not your first time to see this word. The first one is the ratio. This is sine, and it is opposite out of hypotenuse. Then this is cosine, is adjacent out of hypotenuse. Then this is tangent, it is opposite, okay, over adjacent. So in case you happen to forget, write down this word. You'll be able to remember which sides of the right, which ratios of the right angled triangle will give you sine, cosine, and tangent. Okay, something so simple. Okay, at this level, we also consider the reciprocals. Okay, the reciprocals. We look at the reciprocals. The reciprocals of these trigonometric function is cosecant. Okay, you have the reciprocal as cosecant. Oh, sorry, there is something here I'm trying to. Okay, they are cosecant. We have the secant and the cotangent. Okay, so what is cosecant, which we abbreviate as cosec? The cosecant of an angle. Okay, what is it exactly? What are we trying to discuss? So let's write here something. Say that the cosecant, so we abbreviate cosec and then put an angle theta is the reciprocal of a sine. Okay, and we saw from the right angle triangle that sine was A out of C, so this is going to be C over A. Then we have the secant. Okay, sec of an angle theta is the reciprocal of a cosine. Okay, which is going to be C out of B. Then the cotangent, which we're going to write as a cot of an angle theta, is the reciprocal of a tan. Okay, and the tangent, since tangent is sine out of cosine, the reciprocal becomes the cosine out of sine. Okay, and then this is going to be B out of A if you are looking at the triangle. Okay, so cotangent is cos over sine, and the tangent is sine out of cosine. So this is important, something important to note about a right angled triangle. If we have a right angled triangle here, and we consider our angle as theta, okay, so this is an angle theta. So this angle is theta, okay? We also have some angle here, alpha. The side opposite theta is A, okay? And this is adjacent to A. Then this is maybe side C, the hypotenuse. Now, the sine of theta is opposite out of hypotenuse C, okay? Now, when we go to the angle alpha, the side facing alpha changes. So, the point I'm making is that the opposite and the adjacent change depending on the angle under consideration, okay? They are not fixed sides, no, okay? In this case, for alpha, the sine of alpha, the opposite side is B, and the hypotenuse never changes to C, okay? The cosine of theta is adjacent, which is B out of C, and the cosine of alpha is gonna be, okay, the side which is adjacent to the opposite side. This, in this case, is A out of C. So the point I'm making is this: don't think that the opposite and adjacent are fixed sides. No, they vary depending on the angle you are considering, okay? And that's why you start the sine, in this case, sine of theta is equal to cosine of alpha. They are the same, okay? Sine of theta is A out of C, and the cosine of alpha is A out of C. In fact, that relation is going to be so important. The sine of an angle theta is going to be the cosine of 90 minus theta, exactly the same. But this will be discussed as we move on. Now, what next are we looking at here? I want to talk about the general angle. The general angle, okay? In the general angle, we are going to talk about measurement of angles, okay? All angles are measured. All angles are measured from the positive x-axis. You have talked about the coordinate system when you started studying mathematics, I think since primary. So when we're measuring angles, we start from the positive x-axis as a reference point or a starting point. All angles are going to be measured from the positive side, okay, of the x-axis. Now, it's the direction in which we measure the angles that determines if an angle is positive or negative. So, let's start the positive angles. Positive angles are measured in an anti-clockwise sense. Okay, negative angles are measured in the clockwise sense. Okay, in the clockwise sense. So if you start from, we have this as the x-axis. Let's say this is the coordinate system, okay, and this is the x-axis, and this is the y-axis. So this is the negative side of the x-axis, and this is the positive side of the x-axis. So what we do when we are measuring angles, we measure from the positive side of the x-axis. So you start from the positive side and either move clockwise or anti-clockwise. If we start from here and move in that direction, okay, then these are positive angles. And if you start from here and move in the clockwise direction, these are negative angles. Negative angles. For example, if I want to measure an angle which is positive 30 degrees, what I do, I start from here and go 30 degrees in the clockwise direction. So this is 30 degrees. If I want negative 30 degrees, I start from here and move negative downwards. So this is gonna be negative 30 degrees. Okay, so a negative angle is determined by direction of measurement, and the same apply to a positive angle. Okay, you discover that in these two cases the angle is of magnitude 30 but in different quadrants. We're going to talk about quadrants soon. So this is important, and we will make use of it as we move on. Remember, we are still introducing trigonometry. Okay, so we can see that angles are measured in degrees or radians. Angles are measured in degrees or radians. So you measure angles in either degrees or radians. How do we convert from degrees to radians? That's so important. So we see that a circle is considered to be divided into 360 degrees. Okay, the conversion from degrees to radians is based on the fact that 360 degrees is equal to pi, okay, or pi is 360 degrees divided by 2, which is 180 degrees. Okay, pi is 180 degrees. Okay, that's the conversion. We base on that conversion to move from degrees to radians. Okay, but you know, there's this. Okay, let me talk about it. You may find it somewhere useful, mostly to the physics students, because this notation I have seen so much in physics. So we say that each degree may be further subdivided into 60 parts, okay, called mints. And in turn, each mint may be subdivided into another 60 parts of the second. See, okay, so we can start 1 degree equals to 60 minutes, which we just write as 60 with something like that, like a small kind of apostrophe, okay, a small kind of an quite inverted comma, okay. And we can see that 1 minute is equal to 60 seconds, which is okay. Now there's something here we have to note. Students, maybe, and their parents should be careful not to confuse the minutes and seconds used to measure angles with the minutes and seconds used in measuring time. Now, we are talking about minutes and seconds, but these are not the same as the ones we use in measuring time. Okay, look at this example. You express the angle 236.345 degrees in degrees, minutes, seconds. We abbreviate this as DMS notation. So this is simple. What we want to do is to convert the decimals into minutes and seconds. That is it. So if you have 236.345 degrees, write this as 236 degrees plus 0.345 degrees. Then you multiply the decimal by 60 to get the minutes. So this is 236 degrees plus 0.345 times 60 minutes, okay? 60 minutes. Let me rub this. Times 60 minutes. So what do we get? What we get is, we get something like 236, okay, degrees plus 20.7 minutes, okay. So we can go ahead and write this as 236 degrees plus 20 minutes, then plus 0.7 minutes, but convert this to seconds, okay. So therefore 236.345 degrees will give us 236. Those are degrees. Okay, it is in whole numbers. Then 20 minutes, and then 42 seconds. Okay, that's something I just want to talk briefly about. You may find it, you may not find it, but if you find it, then you know that this is a notation. They're just trying to convert the fractional part of degrees into minutes and seconds. Okay, so we said that we can express angles we can write angles in degrees or radians, and we have got the conversion from degrees to radians. Let's look at this. Express 300 degrees in radians. Okay, so the conversion is simple. 180 degrees is equal to pi radians. Okay, and 1 degree is gonna be pi out of 180 in radians. Okay, so if you want to express 300 degrees to radians, then it's going to be, each degree is pi of 180 in radians. So this is going to be 300 times pi out of 180. Then you end up with, by 6. 6 goes into 30. How many times 6? Okay? No, 5 rather, not 6. So this is 5 pi divided by 3. Okay, you have expressed from degrees to radians. Okay, let me give you something here. Okay, let's convert the following to radians. You have the first one is gonna be 120 degrees. Okay, let me do it for you. 120 degrees, each degree is pi out of 180. Okay, so multiply by 120. Okay, by 2, by 6, this is gonna be 2 pi out of 3 in radians. So these will be rads. Okay, then just for purposes of practicing with something simple at the introductory part of trigonometry, what is that? What about 45? Okay, 45 degrees equals, okay, what about 450 degrees equals, what about 15 degrees in radians equals, what about 175 degrees equals. Okay, so just something very simple. Can you convert these to degrees? Convert to degrees. Okay, the first one is pi over 2. I know that pi is 180 degrees divided by 2, so this is gonna be 90 degrees. Okay, so B, you convert pi over 4 radians to degrees. C, convert pi out of 6 radians to degrees. Okay, then you convert 4 pi radians to degrees. Okay, this is, I think this is D. E, you convert 4 pi out of 3 rads to degrees. So now the introductory part of trigonometry, I want to talk about something so simple like that, but we are going to start discussing something very important that you will need at the advanced level. This part aids the understanding of what I'm going to discuss. Now I've designed a program for you. Let me turn on my video. Okay, I'm designing a program for you students because I'm just doing this voluntarily. I'm not charging anything for you. If you want to learn, you can always learn. I have a YouTube channel. Go ahead and subscribe. Hit the notification bell. That way, if I upload a new video, you'll be notified instantly. So, I plan to open a Zoom meeting. Okay, I have a Zoom link, but I plan to have a Zoom meeting every day. Uganda time, I think that's going to be either 4
p.m. or 5 p.m. I had done one at 4 a.m. in the morning, but I have discovered so many people can't, wake up. They're not early birds. They can't wake up early in the morning. So what I'm going to do is to wake up here. Lock time here will be 8 a.m. in the morning, but in Uganda that's gonna be 4 p.m. I think in the evening. So I'm organizing a Zoom meeting starting next week possibly. I'll let you know. If you are interested in the link for the Zoom meeting, you can inbox me. My email is Mwanalisa. Let me see if I can write here. Mwanalisa 67